So today we're still on solving equations, but this is called two-step equations. We now know how to add to both sides of an equation. Subtract from both sides of equation. We know how to take the opposite of both sides of an equation. And divide both sides of an equation. Now notice I'm using shorthand here. I want you guys to start learning to use shorthand as well to take less time to take your notes. Okay, so add to both sides, subtract from both sides, take the opposite of both sides, and divide both sides, right? And when you're dividing both sides of an equation, you divide them into equal parts. And I wrote that out with one word, but you might have written something like into equal parts, right? For shorthand. Okay. So far, we've used these tools one at a time. So we use them one at a time to solve equations, but now we need to be able to use them in combination, right? I'm just going to write combo there for note taking. So we need to be able to use them in combination. When solving an equation, the focus should always be on getting a single x by itself on one side of the equation. On getting a single x by itself on one side of the equation. Use whatever tools you need to do this, so long as you keep the scales in balance. Okay, so we can use any of these tools, the adding, the subtracting, the taking the opposite, the dividing, to solve equations, okay? So we're going to start out solving 2x plus 3 equals negative 5. Now modeling it, we know how to model it, right? So 2x plus 3 equals negative 5 is right there. And we know we're adding positive 3. We've got these positive 3 tiles we need to get away. So if we want to take away, so we've got these x's and we've got these 3. We've got 2 x's and we've got these 3. So the first thing I want to do is I want to try to get my x's all alone. So here are my x's. I want to leave these alone, so I better take these away. So I'm going to take them away. But whatever I do to one side, I need to do to the other. The only problem is I don't have 3 positive tiles. So I'm going to put down some 0 pairs. So I have 3 positive tiles, right? So I took 3 positive tiles away from both sides. That was my first step. And now I have 2 x's over here and 1, 2, 3, 4, 5, 6, 7, 8 tiles, 8 negative tiles over here. Now you might want to redraw this for the next step. So I'm actually going to redraw the scales on the back. So I'm going to take this for more room. You don't have to if you want to draw it, but I know I have 2 positive x tiles and I want to show it in 2 groups. And I have 8 negative integer tiles and I need to divide them into 2 groups. So now I've taken 2 steps to get the x all by itself, but I can see that x equals negative 4. So x equals negative 4. Now you could have arranged that over here. You could have just said, okay, I'm going to divide this into 2 groups, and I'm going to divide this into 2 groups, right? And you could have matched one up. So however you want to show that division, as long as you can show it and you know that 1 x tile equals negative 4. So that's how you would model it on the sentence met. Solving algebraically, we always just start with our algebraic sentence. And we go through the same steps. Remember, the first step we did was to take away 3 positive tiles. We want to take that positive 3 away. But whatever you do to one side of the equal sign, you have to do to the other. And notice I'm putting the negative 3 right under the 3 because those are like terms. And over here, these are like terms. So what I have left on this side is a 2x, right? Remember when I took that 3 away, what I had left was a 2x. 2x on this side. And then I've got a negative 5 minus 3 is a negative 8. There's still an equal sign in the middle, right? So notice when I took the 3 away, that left me with a one-step equation. And now I've got x being multiplied by 2, and I need to divide that into 2 groups. But whatever I do to one side, I do to the other. So x equals negative 4, because 2 divided by 2 is 1. That's 1x. Negative 8 divided by 2 is negative 4. So both ways we get a negative 4. And now we're going to check ourselves by plugging this back in. So instead of writing 2 times x plus 3, I'm going to write 2 times negative 4 plus 3 equals negative 5. And I need to ask myself, is this true? Is this a true statement? Well, this is going to take a little more work. I need to do 2 times negative 4. 2 times negative 4 is negative 8. Then add the 3. Is negative 8 plus 3 equal to negative 5? Yes. So now that we've got a couple steps, this check is a little bit harder. It's also harder to guess our x from the beginning. That's why these tools are so useful, because we don't have to guess our x from the beginning. We can just use these tools to get x by itself. Okay, so the second example, we've got 11 equals negative 4x minus 5. Okay, so I'm going to do the steps over here and the steps over here together so that we can see how they match up. So I've got 11 tiles over here. And I've got negative 5 over here. And negative 4x tiles. Okay, because that's a negative 4. And remember, subtracting 5 is the same thing as adding a negative 5. Okay, so 11 equals negative 4x minus 5, right? So the first thing I need to do is get rid of these negative tiles. And I'm going to use, we were subtracting, so I'm going to use addition as the opposite. I'm going to add 5 positive tiles to make those 0 pairs. But what I do to one side, I need to do to the other. So that gets rid of these, right? The reason I decided to get rid of these, I wanted to get all my x tiles by themselves, right? So once I get rid of these, I get all my x tiles by themselves. So the way to show that algebraically, I'm going to add 5 to this side, and notice I'm matching up my like terms. 5 and the x term don't match up, but the 5 and the negative 5 do. And then over here, 11 and 5 are like terms, so I match them up. What I do to one side, I have to do to the other. And now, when I add down, 11 plus 5 is 16. That matches up with what we see over here. Equals, and then negative 5 plus 5 is 0, so these cancel. That's what we saw here. And we're left with negative 4x. That's what we see here. So really, we're just writing down what we see. And now we've got the situation where, again, we need to divide the groups into 4. But the other thing is we need to take the opposite. So I'm going to draw another step down here. What I want to do is I want to take the opposite of both sides because I don't want to know what a negative 1x is. I want to know what a positive 1x is. So I'm going to arrange these 4 tiles this way. But when I take the opposite of this side, I need to take the opposite of that side, right? So I'm going to make these negative now. So notice I did 2 things in one step. I divided them into 4 groups, and I took the opposite of both sides, right? So now it's in 4 groups, and I can see what 1 positive x is. 1 positive x is equal to -4. Now the way we do that over here, you can take the opposite of both sides and then divide by 4, or you can do it in one step, divide by that -4. So if you divide, because right now x is being multiplied by -4, dividing by -4 is the same thing as taking the opposite and splitting it into 4 groups. And that's what we did here. We took the opposite and split it into 4 groups. So if you see -4 divided by -4 is 1, that just leaves 1x equal to 16 divided by -4 is -4. So we got the same answer both ways. And now our check, we need to take this number and plug it back in the equation. So instead of writing -4x minus 5, I write 11 equals -4 times what I think x is, -4 minus 5. And again, now we have to work this out to see if it's true. What is -4 times -4? That's positive 16. So does 11 equal positive 16 minus 5? Yes. So I know that my -4 worked. So -4 is the solution.